Came to a 2005 Dodge Caravan with a crank no start auction car or something like that. It did have a code for a P0688 when I checked it with the scan tool, and that is for an ASD relay circuit malfunction. On this diagram, unfortunately, I found that the terminals don't match exactly what I have. They say 86 and 30 are hot. And actually, what we found here is that, let me see here, this terminal and this terminal are battery voltage. This is the relay feed to the ASD feed to the rest of the vehicle, and this is the ground from the PCM. So if you look at the relay, I don't know how good this is going to come out. When it plugs in like this, and you flip it back like that, you have 86 and 87 are actually hot all the time. 30 is the output to the rest of the vehicle, and terminal 85 is the ground from the PCM that we're supposed to have. So to go along with doing voltage drop testing, like I said, you always want to have a good ground. Go ahead and ground this like that, and also you want to make sure the circuit is live, and sometimes that can be a little more trickier than not. I'll get everything untangled here, get our meter hooked up. Let me put this down for just a second, guys. Okay, so we got our good ground now, and we have our meter on volts, on the volt scale, and testing for our 2 powers into this relay would be those 2 terminals, like I said. Now, this would be called front probing, which doesn't always give you an accurate reading, but it does give you a reading. And we have 12.3 volts on this circuit, 12.3 volts on that circuit. On the output, we have 0.447 volts, which I believe is backfeeding from the PCM. That is the output of the ASD relay. And then on the ground side circuit, we're showing 0.8 of a volt. Okay. Now the proper way, like I said, to do this is with the circuit live. So we'll plug in our relay. The ASD relay on these vehicles does not turn on all the time. It only turns on when the PCM commands it to. So it's usually a few seconds after key on, a few seconds after key off. And you know, if it doesn't see the engine running, it will not turn off. So I'm going ahead, and what we're going to do is test our ground side to our ASD relay, and I'm having trouble with holding the camera and doing everything here, of course. Okay, so when we have the relay plugged in, we're seeing 12.3 volts on the ground side of that relay. The ground side of that relay will show that as long as it's not energized. And if we go ahead and take this with us to the inside of the car, and we'll go ahead and crank it. I'll first turn the key off. That's key off. That's key on. There's cranking. That means we're not getting a ground from the PCM to the ASD relay. You see, our voltage never went down. The ground, you should always have the voltage go down. So if we want to test another point in this circuit, we could test at the PCM. We could test at the PCM to make sure it's grounding that circuit there, or we could test on the back side of the integrated power module, which is the whole fuse block assembly, this whole thing here. But actually what we're going to do is we can get real easily to C3, that's connector 3, terminal 16, which is a brown and white wire. Now I already did have this back probe in there. I have a probe in here. Now this type of probe is what you call intrusive testing. It's a hook probe. It does poke a hole in the wire, and you do want to make sure that you seal that wire up when you're done with the repair. So I do have that hooked up there, and I will go ahead and hook this up here like that. And now I'll do that same test. Now we're actually seeing the same voltage on that side of the wire. Let me get this so it's not grounding out. we see basically our key on voltage. That's just like we were before. You're seeing a voltage come down through the primary side of the relay and out and back to the PCM. The PCM is not grounding it. Now if we watch this and go ahead and turn the key off, that's key off, there's key on. Now we went down to 0.6 of a volt. Now if we go ahead and crank this, we're still seeing 0.6 of a volt. Now 0.6 of a volt is on the high side for ground. I don't usually like to see more than half a volt. However, we can see that the PCM is trying to do something, but we just don't know why. Apparently the ground is not going through, because we didn't have the ground here. We did not have the ground here at the relay, but we do have it here. So what we can do is actually take our negative lead off of our battery and put our negative lead onto our our primary side control of the relay. And what we're actually doing now is a voltage drop between terminal 85 and between terminal 16 of connector C3. Now if I go ahead and crank this, we'll watch our voltage. Now we're even just with a key in the on position, we're seeing a 1 volt drop. Now, like I said before in my other video, on a single piece of wire you should have a very, very low voltage drop. Extremely low. You know, 0.001 volts, a thousandth of a volt, maybe a hundredth of a volt, but not much. This is showing 1.2 volts are dropping across that single section of wire. If we turn the key on, all of a sudden we have an 11 volt drop when the computer tries to power up that ASD relay. 11 volts being dropped across that section of wire. Now, I can't guarantee it's a section of wire. I've never really taken one of these apart. However, the one thing I should check is make sure that our terminal connection is clean at this connector. But the problem's probably lying in here. So to check that terminal, make sure it's clean, we'll actually disconnect that connector, which is going to be a little bit of a hassle. I have to put the camera down, you guys can watch them over there. Nothing like the Chrysler connector position assurance tabs, always causing a bit of a hassle on these corroded Cleveland cars. You may have to disconnect a couple other ones to get in there. Okay, we got that tab undone. And we go ahead and take the connector out. And this is the connector that I'm seeing. And we're actually after the brown and white wire here that we were probing into. There's our brown and white. And that goes up to this terminal here. This terminal 16 with connector C3. Now at this point, if I wiggle it, I'm trying to wiggle it and make sure that this wire isn't loose or badly corroded or anything going on like that, and it seems to me like it's in relatively good shape. So at this point I'm going to condemn the integrated power module, but that's how you do a voltage drop. We were actually testing a voltage drop between that point and that terminal of the relay. If you know, if there is a possibility there's corrosion or something, I can't see it, or the wire could be bad, but I'm not going to count on it at this time. The next step I could do to verify that that isn't one of our issues is actually back probe. This is how you back probe test the connector. If we can get it in here and get a reading. So we're back probe there, and we will take our negative lead and put it back where we were before. And we'll do our voltage drop test. And we're seeing 5 volts. Oh, it was out of limits. It was high for a second. Okay, we were doing our voltage drop testing and I got a weird reading when I back probed. That's why you always have to back probe. We back probed terminal 16 and we were having 7-volt drop across it. And I went ahead and tugged on it. Let me see if I can get a better view here. And this is what come out. This is the primary side control feed from the PCM. Trying to make sure, I don't know how good the colors come out here, but this is a green wire. It is all corroded. And it just, basically I tugged on it and that's what we got. So I don't know how we're going to go about fixing this one, whether they're going to get a junkyard connector, snip it and rewire everything, or get a terminal and actually repair it the proper way. But this is what was bad. We were reading 7-volt drop across that when we back probe. That's why you always have to back probe.